Hi, my name is Matthew Brenneman, and I'm an instructor here in the mathematics department at Embry-Riddle Daytona Beach, and I want to welcome all of you to the online version of MA242. I hope everyone's doing okay under these trying circumstances and that you're staying well and safe. I know this is probably new to a number of you, myself included, and so essentially what we're doing is we're having these video lectures as substitutes for our actual in-class lectures. And the handouts that I'll be going through in this video will be posted on Canvas, and your instructor will be able to tell you where they are. One thing that I want to emphasize about this online sort of approach, while it's very useful in a lot of ways, I mean, you can stop the video, and think about things. You can watch it at your own convenience and things of this nature. The one potential challenge is the fact that you don't have the ability to ask questions during the lecture. Getting help is really imperative in an online course. And while we're going to have online office hours and things of this nature, you should always feel free to reach out to your instructor with any sort of concerns or questions you might have. Um, Circumstances like ours are kind of like hurricanes, right? A lot of crazy things can happen, and as long as you let us know, communication really is the key here. We'll be able to help you and work with you, and we can overcome any sort of difficulties you might have. Where I want to start in this series is, pardon the pun, a really brief review of what you learned before we left for break. And so we were starting to talk about infinite series. And so if we just look at what the word series means in and of itself, a series is just math speak for sum. And in mathematics, we introduce a compact sort of notation to represent sums. And the first thing we do is we generally re-express the terms that we're summing as elements of some sequence. So if I wanted to add, for example, 1, 2, 4, 8, and 16, I might realize that I can write 1 as 2 to the 0, 2 as 2 to the first, 4 as 2 to the second, and so on. In other words, I could write these elements as the sequence 2 to the nth. And n here is called the index. So n is just a way of identifying what position the element has in the sequence. This is sometimes called an index. And so once I'm able to express the terms in the sum in terms of some sequence, I can go ahead and I can use this really compact way of expressing sums that sometimes is called summation notation. And so we introduce this symbol, sigma, and it really is an instruction. It's telling you to sum. What is it that you're summing? Well, you're summing what is to the right of it, which is commonly called a summand. This represents the terms of this represents the sequence whose terms that you're actually summing. And so we have to tell this set of instructions at what part in the sequence we want to start summing, and this is indicated by what we call the lower index. So this is saying take the sum of 2 to the n starting at n equal to 0 and going up to n equal to 4. So this is called the upper index. And it's kind of worthwhile noting, and in fact we're going to explore this analogy a little bit further when we talk about the integral test for series convergence, that a series, sorry, not an infinite series, don't want to quite go there yet, but a series is a lot like an integral. If you think about an integral, you can think of it as kind of a continuous sum. So here, the series is a discrete sum. Okay? And the things that we're summing up, well, in a series, we denote these by a sub n. And of course, in an integral, this is the integrand f of x. Where we start the integral is a lower limit of integration. That's like our lower index. And where we end the integral is like the upper index. So our upper limit of integration is like our upper index. And so when we get to infinite series just literally means an infinite sum. And so the general form is that we usually start at a specific place. So here I might start at n sub 0, and I'm going to basically add the terms that are in the rest of the sequence. So basically we're going up to infinity. Okay. Now, it's a little cumbersome to write this because notice that this is a little confusing. This is the index n. This is an actual number that I've left unspecified, n sub 0. And of course, this could be anything. And so instead of writing this more cumbersome type of notation, I'm going to sometimes write this more general notation where this is implied to be an infinite series, but I'm just not specifying where it's starting, but it is going out to infinity. And one of the things to realize, and the difference between a series and an infinite series, the biggest difference is that a finite sum will always exist, but an infinite series or an infinite sum may not exist. And so in the next video, we want to talk about what it means for an infinite series to exist, and that naturally leads to the concept of convergence.